Are you ready, kids?
Aye, aye, Captain!
I can't hear you!
Aye, aye, Captain!
Oh! Who lives in a pineapple under the sea?
Stoichiometry.
Stoichiometry, the study of quantitative relationships between amounts of reactants used in products formed, follows the law of conservation of mass, meaning the chemical equations will be balanced. The reactant in excess relies on the limiting region in the chemical reaction. Precipitate, or the cloudy substance in the solution, proves the chemical reaction takes place, and the other clear liquid is referred to as the supernatant. In this case, copper sulfate serves as the precipitate. In our lab, we observed a chemical reaction between a fixed amount of potassium hydroxide and copper sulfate. Copper sulfate was clear and potassium hydroxide had a blue tint. This is a double displacement reaction, meaning the ionic compound switch cations. We measured with borates a specified amount of copper sulfate, 5 milliliters to be exact, and added increasing amounts of milliliters of potassium hydroxide into test tubes. Following the mixture of potassium hydroxide and copper sulfate in the test tube, we also filled each test tube with enough water to have a total solution of 13 milliliters. After 15 minutes of letting the test tube sit, we recorded the height of the precipitate in millimeters of each test tube. The products turned a darker hue of blue than the original copper sulfate, and the color separated. The precipitate was evident as clear fluid settled on the top, and light blue precipitate sat at the bottom. We observed the reactions taking place, noticing the amount of precipitate levels off in the test tubes 5, 6, 7, and 8. After analyzing the trend, we came to the conclusion that in the first 4 test tubes, potassium hydroxide was the limiting reactant, as the amount of precipitate increased as potassium hydroxide increased. Furthermore, for test tubes 5 through 8, the leveling off of the precipitate shows that potassium hydroxide became the limiting reagent, as there was a limited amount of product being produced. In test tubes 1 through 4, potassium hydroxide was completely used up in the chemical reaction, and in test tubes 5 through 8, copper sulfate was completely used up. The volume ratio of copper sulfate and potassium hydroxide that seems to produce the maximum amount of precipitate seemed to be 8 milliliters of potassium hydroxide to 5 milliliters of copper sulfate. We made slight errors in test tube 7, having less precipitate than should have been to prove potassium hydroxide to be the limiting reactant in such quantities. We likely didn't add enough potassium hydroxide and copper sulfate to the test tube in accurate amounts. Therefore, the height was slightly off to prove the limiting region. In observing the chemical reaction between copper sulfate and potassium hydroxide, we determined the limiting region at different ratios and learned more about stoichiometry in real time.